Hey guys, welcome to another YouTube video. Today we're going to be treating question on motion. That's we want to understand when you drop a body, what actually happens, what goes on. So this is a question under that very aspect. They said a ball is dropped from the hand, it falls on the ground and it bounces back up and down with decreasing velocity. That means it will stop at some point. Then they said draw a velocity time graph of the motion, one, and two, using the graph, state how the distance of the ball falls and rise can be found. So let's proceed straight away. So our answer. Okay, so you need to be very imaginative and really understand the concept of when you are dropping the ball. So when you drop the ball, what actually happens is that the velocity is starting from zero and it keeps increasing till it hits the ground. Then when it hits the ground, there's something we call instantaneous velocity. That's at an instant in time. You understand? So immediately it hits the ground, it shoots up with in an instant, like with immediate effect. So we have to really show those things on the velocity time graph diagram that we want to draw. Okay, so we proceed. So you draw your time graph, which is velocity in meter per second against time in seconds. Okay, so we said the body is starting from a velocity of zero. So our downward motion, let's use the downside of the graph to show our downward motion and the upside of the graph to show our upward motion. So you say it's starting from zero. When you drop the body, the velocity is going to be increasing gradually. Then immediately it hits the ground, it's going to shoot up at an instant. You understand? It's like as it's hitting the ground, it goes back up again. Okay, then what happens again? It goes through that journey again, it goes down. Then when it hits the ground again, it what? Shoots up. Do you understand? Then it goes down again. Sorry, it goes down. Then immediately it shoots up again. And finally it goes down. Let's say it comes to rest at that point. So you can see what's happening. The body falls, increases its velocity, but immediately it hits the ground and is going back up. You understand? The velocity doesn't change. You understand? It's instantaneous. It bounces back up. It's immediate effect. It falls down again, bounces back up again till it has no energy again to keep on bouncing till the velocity totally becomes zero for both the upward and downward motion. So this is how the velocity time graph will be. So to answer the second question, which is actually the distance the ball falls and rise, we have, let's label this. So let's call this point O. That's the origin. Let's call this point A. Let's call this one B. Let's call this one C. Yeah, I think those are the ones we need. Then I think let's call this point, this middle point here, let's call this one P. And let's call this one Q. Yes. So diving to the second part of our question, they said using the graph, state how the distance the ball falls and rise can be found. So normally, whenever you want to find your distance on the graph, all you have to do is to calculate the area of that particular portion that you are looking for the distance. This is what I mean. So, for example, the distance this ball falls is OP bar. The distance the ball falls is OP. Now I'm telling you that if you want to find the distance the ball falls there, all you have to do is to calculate the area of this triangle. Triangle what? OAP. If you calculate the area of triangle OAP, is going to give you this distance OP that you are looking for. in a velocity time graph, when you calculate the area of that portion, it's going to be with this distance from here to here. Meaning, if you want to know the distance the ball rises, which is what PQ, if you want to find the PQ, distance ball rises, is going to be the area of what? Area of triangle what? BPQ. BPQ. That's what is going to give you what? This distance. Hope you understand. Yes. So we have answered the two questions. Now let me give you an extra information. Yes. When you are asked to find the acceleration for this graph like this, all you have to do is to take the gradient of the graph. Of course, you know acceleration is velocity over time. So if you see your velocity time graph and they ask you to get your acceleration from it, just take the gradient. You understand? Pick a starting point, pick an ending point. You understand? Find your x-axis, your y-axis. Your x-axis is time, your y-axis is velocity. Choose two points and calculate your gradient. That's how you find your area. So three things that we have learned. Number one, how to understand the velocity time graph, how to draw the velocity time graph for a body that falls, a ball that falls and keeps on bouncing. Number two is to find the distance the ball rises and falls. And number three is the extra information, which is how to find your acceleration. Yeah, I hope you understand, and if you have any question, please drop it in the comment section. Yeah, thank you.